Hi everyone, welcome to the ArxLang channel. My name is Ivan and today we will talk about the implementation for the LLVM IR in ArxLang. Alright, the previous streaming was about just the basic idea, what we need to do in order to have it done for our compiler, and we have some files already created, and now we just need to finish the code. All right, so if you recall correctly, or actually if you recall about our previous streaming, we mentioned that this part of the compiler will be based on the chapter 9 of LLVM Kaleidoscope tutorial. Okay, so let's jump to that. Basically, we want to get the code here that is specific for debug, or it's kind of or it's using emit location. Okay, not sure if we can finish that today, but at least I think we can do like the basic structure, and I hope we have something near to done today. Okay, so basically we want this debug information. Let's go. All right, I need to actually now I will present and share my screen of the VS Code. Okay, I think that will be better, and close others. All right, so the changes we did in the previous streaming, we managed to have that compiled, so that's good. It seems that at least the structure is working, and now we need to put the missing pieces. So let's go to the top. We have here the visitor. Probably before the visitor would be okay. Just remember to add the LLVM namespace here, because we are not using it directly. It's more verbose, but it's more explicit. Something that we are using for this compiler, some like philosophy is explicit is better than implicit. Okay, so we are trying to use always the namespace in the variable or the object here. Cool. Okay, so okay, it should be okay here as well, and the name of the object should be this one. Okay, actually we will move this to the AST. So and this one. Alright, not sure, maybe at the end, so we can add just the debugging stuff. Debugging info. Alright, and the next step will be, it will be hard to change to switch between the windows, but doesn't matter. So let's go. So the next step will be check if we can find inside the code anything about that, and probably we need something like ident. It's possible, not sure. Let me control F. Yeah, we need this ident stuff. All right, so let's go back here, ident, and probably we can have it inside our visitor to LLVM. I think that's okay. And we can have it right here. And again, I need to change it to VS Code. Here, probably this is LLVM. Same here. Can use the auto format, the redirection here, the return type information. All right. Oh, okay. I think that should be okay for this. Let's go back to the web browser. The next step will be, maybe it's not about the parsing, or maybe the parsing as well. Oh, they have like, maybe we will need something different. Maybe we will need an extra visitor for this. Okay, yeah, it's online and on air pre-programming session, so probably a lot of things will change during this presentation or during this request. So yeah, we need to be prepared as well. So AST to dump. Okay, and it's public visitor. All right, class here. And it should be, we can change it from dump to visit. Oh, actually we need something different, I guess. Of course it depends on where we will plug this visitor stuff, but yeah, let's try something different. So let's call it result. Actually, LLVM. Result. This will be something like auto visit and void. Here we are returning everything, but actually we needed to change to this result. Of course we don't need result this here. I prefer that because I prefer explicit than implicit, so it's really easy to just take a look here, and with no time I can say, oh, result is an attribute of my class, you know. So that's the reason I have this here, but of course we don't need that. It's just to be more explicit. Probably is not the common way to work with C++, but yeah, as I mentioned in the Arx workflow development, we prefer explicit than implicit. All right, maybe this get line, not super sure if we should use that here. It's a good question, actually. It is really related to the AST object. Of course, this is more for dump than anything else, right? It will help us to get more information about the AST. But yeah, as I mentioned, it's a bit complicated right now. This is for the AST, so it should be available for everything else in the code, but it seems also the other ones are implementing that, like the number expression as well, maybe with some differences. Out. Yeah, that's a good one. We have the return, and to that return, or that input in this case, we want to add the get line and the get call. It's very interesting how maybe we can have something different for now without this information. All right, let's try something different for now. I think maybe we can focus on the information than the get line and get call, at least for now. So I will keep it as a comment, and this, just that. And let me change it to std and line. All right. Actually, we have the out, we have int, but also we need something different here. This visit will be tricky for what we have, because actually what we need is something like this, right? But how to receive all this information? And I think that's the point, right? Because actually what we need is something like this, right? Okay, let's change there is some ideas here. All right, because this is just for the dump stuff, but also let's take a look into the code, so we probably will have more ideas how to move it forward. Okay, so we have sorry, we have here the dump. We are defining how we want to dump the unary. All right. Okay, I think we can move forward to the code generation, so maybe we will have a better understanding about this, because maybe the dump stuff will be a different also translate unit translate, or translate to unit, or a C++ file. So maybe we will need to have the debug stuff in a different file. So let's move forward. If we can see anything else different here or interesting that will give us some ideas. right, parser. All right. All right, I think this is the point about the code generation. So we have these as well. Let me copy these and move to the VS Code. This is a function. All right. Let me put it to the visitor for now. This indent looks more about the debug than the LLVM, right? So maybe for now I will move this to here, at least for now. All right, let's go back to the web browser. Also, we have a lot of things here. Sorry. We have these 3 other functions we need to move to there. Oh, all right. Web browser, VS Code. All right. We don't need the static. Let me try to fix the format. We don't need this static here. This probably is LLVM. Probably can just change it to auto, and we can add the type here. Debug info. Oh, I see. In this case, this is an information for debug, a method for debug info. All right, it's different. Same here. Oh, my bad. So both, and this is a LLVM. So here. All right, that should be okay. Inside here we need to that's a good one. So the point here about these chains is that inside the original file, the original LLVM kaleidoscope, everything were declared and used in the global space. Okay, so now we are creating things more isolated. And for that reason, things start to be a bit complicated. Okay, maybe we need to do something different. For example, maybe the debug info should have builder inside as an attribute from our visitor. In some place we have the builder here. Okay, here. So maybe we should declare debug info as part of the our visitor class here. So here we have the attributes. So maybe and just maybe we should instantiate that with the builder information. And yeah, I think that we will need the builder. This is double TI. So let me try to use this. WTI. This should be this as well. Okay, this DARF, we're not really sure. I guess it's LLVM as well, but we need to check that. Maybe not. Yep, let's keep it for now, and I will try to find it soon. Maybe we need to check the imports first. So let's go to the web browser. We have extras. Yeah, from the top of my head, not super sure if we have something for DARF, but we can check the imports if we are missing anyone. So STL extras, it's here. Basic allies analysis. Oh, something really important that we should do first is probably we don't want to use directly the Kaleidoscope tutorial page, because maybe we have some conflict about version. So probably the best way to go, but the best way to get what we need from the LLVM Kaleidoscope to use to our inside our Arx compiler is using the GitHub repository. In this case, GitHub LLVM Kaleidoscope. Probably something near here. Okay, we are using the version 15. Probably 15.03 maybe, or 4. Let's try 4 for now. The conda list grep LLVM. Six. All right. We have here, we needed the chapter 9, not chapter 8. Right, the toy CPP file. So we have extras, we have basic LLVM analysis, basic allies analysis. We have passes, LLVM analysis passes, LLVM analysis passes, LLVM IR build debuilder, LLVM IR DI builder, IR builder, LLVM context. It seems we don't have the context here. Context. See, yes, we have LLVM context. Legacy pass manager, module, verifier, support host, target, support target select, transforms scholars, and ctype stdio map string vector, and yeah, I think we have everything, so that's good. The next step would be to check. Basically, I think we don't have any change here, or maybe we have a vector here. Let me check if we really, yeah. So probably we don't have any change here because it's basically the same code. but in some cases there are difference between the LLVM functions or methods. Okay, so for now I think we are good. All right, source code and events, blah blah. Stream ident, and this, the dump. Of course, probably the easiest way to do that would be to implement dump into the AST object. The point is if it's useful or not. Here in the LLVM kaleidoscope, basically they are using everything together, so it's not something like composable. And we are trying to do something for Arx, something composable. So the question is if it's worth to use dump inside the AST or inside a visitor, right? I think that's really important. Just to keep things simple, let's try it inside the code, the AST, just to keep our life simple. The ident is a good one. Where to have ident? Ident. This one also is a good question. We have already something for ident in utils, if you recall correctly. So yeah, let's just drop it. Yep, we'll have something inside parser for now, just to keep our life simple. This is something really important. Keep life simple. So let's go to the AST expression. Actually, we need the .h file. As you can see, LLVM kaleidoscope has just one file, and here it's around maybe 20 files. So just to keep in mind the difference between both source code. It's although they are using a very similar code, the Arx language is based on LLVM to the kaleidoscope tutorial, but the work we did on Arx to keep it as a more robust compiler is a lot of the work we did. So of course the structure is really similar yet, but I think until the end of the year probably it will be really different. Okay, so we can add now our dump. All right, this is our dump. Let's use the explicit approach. This is the line. Let's reformat this. Okay, it seems it's good. Row streaming, not sure, but maybe LLVM. Not super sure, but I can try here. Maybe we have it in other place as well, and I can check. Yep, it seems it's LLVM row OS O stream. All right, that's good. All right. Okay, and okay. All right. Let's move to another one. We can try to search by dump and use it. Oops, don't change this. This is the number expression. LLVM everything looks good. Let's go to the other one. This be variable. Okay, that's correct. Same thing, LLVM. All right, that's all. Next one, unary. All right, looks good. Next one, binary. Let me check what you are seeing. Okay, I can move to the VS Code. I think that would be much better. Okay, all right. Now the next one is call expression. Yeah, not super sure if this for will work, because also we have unique pointers, but yeah, we change it to strings to unique pointer, but not sure for call expression here. Yep, probably it will not work as expected. So in this case, we need a different for. So just to keep my life easy, I will just copy from the AST to LLVM function. In this case, we have here args. Actually, this args. Can you call it node? It's not a big deal. Okay, I think that should be enough. And this should be node. Yep. All right. Next one. If this streaming is getting longer than expected, so probably for this streaming we will just finish this implementation for the debug, just to keep it a bit easier. Okay. It looks okay. The for expression. It's indent. Not really sure. Of course, we need to use this to keep it explicit. not necessary, but as I mentioned, we prefer to use explicit than implicit. Probably we need to do the same in some part of the code here. Let me see if we need it in other places. Maybe not. Yep. Oh, of course we need operand as well. And I think we are good now. Yep, we are good. Oops, but actually val is that's why I prefer to use this. Everything is explicit always. All right, we are good, and I think we are missing just 3 functions here. The bar expression, same here. Oh, sure. The var names are unique pointer to AS. Okay, so yeah, we need the for. Let's copy this one from here. Let's change it here. All right. Name var probably is not anymore. This should be node. Same here, node. This. Okay. Okay. Everything else should be okay. And let's move to the last 2 functions. It seems we don't have something for prototype. It's interesting, but yes, we have for function. Don't have for prototype, and not sure why, but we have for prototype. Okay. Okay. This should be this. Actually, my guess is that it will be performed similar to what we done for the AST to STD out. It will be performed really similar, this dump function. So yeah, we need to check if we really need these or not. And it seems also that maybe to be used by the LLVM IR functions. So not sure yet. It's just like we are just playing here to see how is it working. How does it works? Oh, my English is really bad today. But we need to see if it really makes sense to keep it here. All right. Not sure that we can build it now. To see if everything is still working or not. It seems not. Check actually, and we had a lot of things. Also, we have a lot. We need something like this here. I need to check a better way to use the builder here, because probably we need, instead of a unique pointer, we need something like a shared pointer. Okay, or maybe, oh yeah, maybe we can do something different if we want to use more than just the builder. Let's use just the builder for now. This is a unique pointer, but we need something like a shared pointer, right? Change it to shared pointer. But for now, we want something like this. I'm not super happy with that, but that's what we have for today. Okay. Let's change, not sure if it's possible, let's change it to class. Let's call everything to public for now. It's just easier. Of course, we need to refactor the code in order to check what is really public or not. But remember that everything here were in the past in the global scope of this file, and it was really bad. And here we need to create the constructor, and for the constructor we need the builder, and we can, maybe we needed to change, also create a destructor for these as well. But for now, let's try this is a builder, right? And that should be okay. Builder. All right. What is that? Debug lock. Debug lock. Where is it from? It's weird because it's not in the code as we expected. Probably it's a new version. Oh, probably we need just to copy this code. Yep. That's why we needed to change our reference from the LLVM page, the LLVM kaleidoscope page, to the GitHub. All right. Oh, but it looks the same actually. So if it's correct, it should be LLVM. All right. Same here, probably LLVM. This looks like objects from somewhere, lexical stuff. Okay, so let's use this. Here, same thing, LLVM. This is the object, this. Same here, this. All right. Scope, AST scope. Okay, looks okay in general. This is from LLVM. Here. All right. All right, let's try it again. What? All right. I think for today it will be a good second step. We did a video streaming previously, actually yesterday, and today we are moving forward with the implementation with the debug information, and also with the LLVM IR output. So I think it's a great step for today, and probably we can do it more tonight or maybe tomorrow. Okay, so yeah, as always, thank you for watching, and I'll see you in the next streaming. Subscribe if you want to receive notifications about new videos, and see you. Take care. Thanks.